Okay, so part two, we're talking about the seasons. So seasons are based on where we are in location and hemisphere of our orbit around the sun. So the changes in daylight hours, the changes in temperature, the changes in which the amount of sunlight strikes the Earth, or the angle at which it strikes the Earth, these all have to do with the changes of seasons. So the variations depend on what it is. So remember, the Earth is tilted at 23.5 degrees on its axis. So we are coming with different angles towards the sun. So, for instance, when we are in our northern hemisphere, we are coming into contact with more sun than the southern hemisphere, creating our opposite of winter and summer. So, whatever the southern hemisphere is in, we are the opposite. So, northern hemisphere is in, we're about to be in the fall solstice, the fall equinox, and that will mean that we are going to be in our autumn or fall, and southern hemisphere will be coming into their spring. So the sun angle depends on how much sunlight you receive. So the higher angles receive when they're tilted, the higher the angles, then the hemisphere tilted away from the sun. So if we're tilted towards it, we're going to get more sunlight. If we're tilted away, we're going to get less. So that creates a difference in temperature. It creates a difference in daylight time, and then also the amount of sunlight for plants and such. So the greater intensity of the sunlight, we are in a summer. It's going to be warmer than winter. If there's less intensity of sunlight, you're going to be in a cooler season. So as the year progresses, the number of daylight hours becomes fewer and fewer. They reach a minimum at our winter solstice. And then it reaches a maximum at our summer solstice. So our solstices are when they are tilted. So when the hemisphere of the Earth is tilted towards the sun, it receives more, and then when it's tilted away, the solstice is the point in which the greatest distance is either farthest or closest to the sun at that point in time. So the point at which the sun reaches its greatest distance in north or southeast of the east equator. So that means our summer solstice is the winter solstice for the southern hemisphere, and our winter is the summer for them as well. Equinoxes are when both hemispheres receive the exact equal number of daylight time. So you are at 12 hours of each. So ours on September 22nd, which is coming up, it probably will be when you're watching this video. That is our equinox for the fall or for the autumn. So you'll have exactly 12 and 12 hours. At that point, we'll start to go less and less sunlight during the day. Let's see. Do we want to talk about the moon and tides? Yes, we'll do moon phases next time. So we talked about rotation and revolution for the Earth. Now let's talk about rotation and revolution for the moon. So we've talked about our relationship to the sun. I want to talk more about the relationship to the moon. So it takes 27.3 days, about 28 days, for the moon to revolve once around Earth. That's why we call it a lunar cycle. So a lunar cycle around the Earth is going to take 28 days. So one elliptic around the Earth is going to take 28 days. But a cycle for it to do one Sidonic month, meaning that it is going to take, for the phases, takes 29.5 days. So because the Earth also moves around the sun, it's going to show different things. So it takes 2 more days for the moon to line up with the Earth, moon, and sun than it does for the moon to revolve around the Earth. So based on the sunlight we receive, we see different lunar cycle. So this is your Sidonic month. The rotation. So the moon keeps the same side facing the Earth because it takes 27 days to rotate once. That's why we call it this is called a synchronous rotation, meaning that it revolves at the same rate that it rotates. This means that we never see one side of the moon at night. So we call it the dark side of the moon, even though it is receiving sunlight when we can't see it because it's on the opposite side. That's why we call it a new moon. The moon affects the Earth. So we talked about this tug of war last time with the Earth and the moon because of their gravity. The same thing goes with, so the Earth is kind of being tugged between the smaller moon and the larger sun, and so that is going to create effects and rises of sea level. So this means we have a high tide when it drops so as the sun gets further away. So 6 hours later, we have a low tide. The sun is moving much further away from the Earth than the moon. This creates the tides in the Earth. So basically, so as the sun is closer, you have a high tide, and as it gets further away, you get a low tide because it is pulling it further and further away. So the Earth's tides are an example of how the sun, moon, and Earth have this system. So when the moon and the sun are aligned, they pull together, and they produce stronger spring tides. When they are not aligned or when they are at right angle, so at your quarter moons, that means that you have weaker tide called neap tides. So spring tides are when they're going to be higher because they're playing tug of war, and your neap tides are when their tug of war is weaker because of the basis of their gravitational or centrifugal force. So as you watch, neap tides are at your quarters, full and new moons are your spring tides. Spring tide, neap tide, spring tide, neap tide. And that's it for today. We'll talk about the moon phases another time.